Hello students, welcome to my YouTube channel. Please do subscribe, like and share videos what I am going to upload. In this series of videos, I am going to teach you the chapter Statistics. It is one of the important chapter and you have studied the basic things regarding the chapter Statistics in your 9th standard. In the 9th standard, you have studied what is actually statistics, what is data, and different types of data. In this chapter also, we are going to deal with more about the data, types of data, and numerical problems. The chapter is actually entirely related in a numerical way, means we are going to calculate numerical problems. So that's why this chapter is very easy if you are very familiar in numerical calculations. In the first video, I'm going to teach you the basic definitions regarding the chapter Statistics. Basic definition means, so first we have to understand what is statistics. That is the definition of statistics. After that, the very important word in the chapter Statistics is data. Okay, so you know this one. In the last year I told for you, data is a plural word. Singular form of data is datum, D-A-T-U-M. So first we have to understand what is data and what are the different types of data. Okay, so after that we are going to deal with problems on data. Hello students. Now let us begin the chapter Statistics. You have studied in the 9th standard about the definition of statistics. I told for you in the last year and I have given an example for you. So first let us see what is statistics. Look at the definition. It says like this. Statistics is the study of collection, organization, analysis, interpretation and presentation of what? Data. Okay, so data means actually what? It is an information what we are going to collect. Whatever the information we have collected, first we are going to organize it. After the collection, we are going to organize and then we are going to analyze the organized data. After that analysis, we are going to interpret that data. Interpretation means explanation regarding the data and also presentation. By interpretation, we can present the data to any other person, and this process is actually called as statistics. So the best example for statistics in the last year I told for you, census is the best example. It will be conducted for every 10 years in our country, and the last census was conducted in the year 2011 and the next census will be conducted in 2021. So during the census, teachers will come to your home and they will collect the data. How many members are there in your family? How many males are there? How many females are there? What is their age? What is their date of birth? How many children are there? And what actually they are studying, and the qualification of all the members of a family. Okay, so many more data will be collected by the teachers. Okay, in this way the entire information means the information of all the members of that country, it is going to organize them. Okay, the collected data then organized. After that it is analyzed. After that they are going to interpret that data. So means after the interpretation they are going to present the data. So during their presentation they are going to give some useful information regarding our country. So like that, so the total population, how many males are present, how many females are present, and how many children are present, and also the very important thing, sex ratio. So means for every 1,000 males, how many females are present. So this is called as a sex ratio. So while collecting the information, they are going to collect the information like that, how many boys are there, how many girls are there, male and female, like that. Okay, they are going to categorize like this. So that's why it will be helpful for them to get the data like this, sex ratio. And one more thing is literacy of our country. So during the collection of data, they are going to collect what your qualification. By the qualification, we can understand what is the literacy of our country. So like this. So this process is actually called as what? This is statistics. Okay, related to the definition, statistics. And the very familiar example is one more example, result sheet. Okay, I think you have seen this one. So while preparing the result sheet, we are going to first arrange the student's name, okay, and the subjects, okay, like data, Kannada, English, science, maths, social, like this, okay, and then we are going to enter the marks obtained by you, and after that total marks, and in the next column percentage. Okay, so by this data, okay, this is actually a data, so the whatever the marks you have collected, whatever the marks you have gained, this is actually what data. After that we are going to make what total marks, we are going to calculate total marks and then percentage, and then we can sort out the result, means from what is the highest percentage, what is the least percentage, how many distinctions are there, how many 90 plus are there, and how many first class are there, second class are there, like that. Okay, to all of the grade, and how many students failed the examination, how many attended, and how many students are absent in the examination. So like this. So these are all the information, okay, what we are going to analyze after taking the data. Data is actually what? The marks obtained by you is called as data. And these are all I have given the two very important examples for you. So these are all the these two are actually very familiar for you, so that's why I have given for you. So the next thing is, so now look at here, I'm going to give an example of a data. Okay, let us look at that one. So now the collection of the marks out of 20 means total marks is actually 20, maximum marks of 30 students of a class 10 in a mathematics test. There are 30 students in a class, in a section, and they have written mathematics test, and it is already evaluated. Out of 20 marks, the marks obtained by the students is actually like this: 10, 12, 20, 19, 17, and so on. Okay, the last two student obtained 8 marks, like this. So this is also actually called as what? Data. This is the example of data. So there are totally 30 data are present. Data are also called as observations. Okay, observations are data, both are one and the same, they are synonyms. So now let us look at more about this one. So now look at here, data is going to classify in two different ways. It can be classified into two different ways. So they are actually, one is grouped data and another one is ungrouped data. Grouped data and ungrouped data. So the difference between grouped data and ungrouped data is, ungrouped means whatever the information we have collected, it is called as raw information. Whatever the information we have collected or the data we have collected, it is normally called as ungrouped data. It is always ungrouped data. Data is called as grouped data when we arrange the given data so as to analyze further. Means the raw data is going to arrange in a particular manner so that it will be helpful for further calculation, like that. So when we arrange the raw data in a particular manner, so that it helps for further analysis, then it will be called as grouped data. Okay, very simple difference is whatever the information, raw information we have collected, it is called as ungrouped data. If you organize or if you arrange the data in a particular manner, then it is called as grouped data. So to arrange data in a particular manner means to make it a grouped data, there are two ways. Okay, so now look at here, there are two different ways. First one is discrete frequency distribution. This is the one way to group the raw data, and another way is actually continuous frequency distribution. This is the another method. So there are two methods to group a data, and this is very important. Grouped data and this discrete frequency distribution, second one continuous frequency distribution. This is actually very important, because in this chapter mainly we are going to deal with discrete frequency distribution, and second one is continuous frequency distribution. So we are not going to deal with ungrouped data. So this is because if it is ungrouped, then we are going to convert that one into as a grouped data, so then it will be helpful for analysis. Okay, so to make it helpful for analysis, it is better to convert the ungrouped data as a grouped data. Okay, so then we will look at, okay, so now look at here, ungrouped data. So this is actually the data what I have given initially for you, the marks obtained by the students, 30 students out of 20 marks in a mathematics test. Okay, so now this is actually called as what, raw data. So okay, now look at here, so this is actually called as what, raw data. Okay, so because it is not actually arranged, now I'm going to group this one, I'm going to convert this one as a grouped data. How can you convert is very important. Okay, so now just look at the data what I have collected. So now look at here, 10, 12, 20, 19, 17 and so on. Okay, so now just look at here, so now here, so now look at here, here 10 is present. Okay, and then so now look at here, here also 10 is present. Okay, in the second row there is no 10, in the third row there is no 10, in the fourth row there is no 10, and in the last row there is no 10. Means by this we can understand what, there are two students who obtain 10 marks actually. In the same sense, I'm going to look at one more category like this. Okay, now look at here, here 19 is present. Okay, here also 19 is present, in the first row also here 119 is present, and in the second row only 2 19s are present, in the third row. So now look at here, there is no 19, and in the third row there is no 19, the fourth row here one more 19 is present. So by means we can understand what, there are 4 students who secured 19 marks. So by looking this one, okay, this phenomena, we can, I'm going to group the data. So means I'm going to assign frequency for a data. So now look at here, here 10 appears 2 times, means I'm going to assign frequency of the data 10 as 2. It means 10 appears 2 times. In the same sense, I'm going to assign 4 as a frequency for the data 19. So this is because 19 appears 4 times, that's why. Suppose if there is a data, it appears only one time. Now let us look at an example. Okay, 9 is present. Okay, now let us look at the number 8. Okay, so here the number 8 is present actually, and in this row there is no 8. Okay, here also 8 is present, so that's why its frequency will become 2. Okay, so now let us look at the data which has only one frequency. Okay, so now I will just look at what 16. Okay, so now look at here, 16 is present here. Okay, so in the next row here 16 is present, you are also 16%. Okay, its frequency will become 2 maybe. Okay, so now let us look at what one more example, so that its frequency should be equal to what 1. So now look at here the 11 number. Okay, so 7, 16, 11, 5, 14, 10. Okay, and then here 11 is absent, and in this row also 11 is absent, and in this row also 11 is absent. Okay, so now look at here. So the frequency of 11 is equal to how much? 1. So this is because 11 appears only one time. So that's why its frequency is equal to how much? 1. Okay, if you do in this way, I'm going to group this one. Okay, so now look at here. I'm going to give you what? Discrete frequency distribution. This is a grouped data. So now look at the table carefully. Okay, so now look at here. Look at this table. Okay, so now look at here. 4 is a data and 2 is actually what? Number of students. Second column is frequency, first column is data. Remember, 4 actually appears 2 times. Okay, you can verify this one. 4 appears 2 times, and 5 data, frequency 3 because it appears 3 times. 7 data, its frequency is 1 because it appears only 1 time. That's why. 8 appears 2 times. 9 2 times. Okay, now let us verify. For 19 is actually what? 4. Okay, so now look at here. At last 19 is present. 19 means 4. Its frequency is actually what? 4. In the same sense, for 20 it is actually how much? 3. And in the same sense, 12 it is 2. 14 it is 2. So means it appears 2 times. That's why. Okay, so this is the first way to group a ungrouped data, and this is called as what? Discrete frequency distribution. So now one more thing. Now look at here. I have not written 3 here. Okay, if you want to write on 3, its frequency becomes 0 because no student gained the marks equal to 3. No students gained 3 marks. That's why if you want to write on 3, its frequency becomes 0. In the same sense, now look at here. 6 is absent actually. I have not written 6. If you want to write on 6, then you have to assign its frequency as 0 because no student gained 6 marks. That's why. Okay, so this is the way how to group a data by in the format of what? Discrete frequency distribution. Okay, so now I will look at one more method that is called as continuous frequency distribution. Okay, so now let us look at the table, then we can understand what is continuous frequency distribution. Okay, so now look at the table. So this is actually continuous frequency distribution. Okay, so now look at here. In the first column, marks, I have written 0 to 5. So this is the range. Now you need to count how many students are there who secured the marks 0 to 5. Okay, including 0 and 5 also. Okay, including 0 and up to 5. Okay, actually you need to exclude 5. 0 to 4 only. Okay, so if you look at here, okay, in this data there are only 2 students who secured marks which lies between 0 to 4. 0, 1, 2, 3, 4. Okay, so in the same sense, for the second one, 5 to 10 means here you need to count how many students are there who secured the marks 5 or 6 or 7 or 8 or 9, but not 10, because if he secured 10 marks, he will move on to the next group. Okay, he will move on to the next group, that is called as a class interval. Okay, so the third class interval is 10 to 15. You need to count how many students are there who secured the marks 10 or 11 or 12 or 13 or 14. Actually there are 8 students who comes in this range, and this second column is normally called as frequency, as in the case of discrete frequency distribution. And the last one, 15 to 20. Okay, so now you need to include 20 here also, because there is no next class interval. That's why. Okay, you need to include, if the student secured 20 marks, you need to include in this group only. So here you need to include 15 or 16, 17, 18, 19 and also 20. So here there are totally 12 students whose marks comes in this range. So, and it is called as continuous frequency distribution. So in this way we can classify the data, like means we can group the data like a discrete frequency distribution or continuous frequency distribution. And this grouped data will be very helpful for you for analysis and interpretation. So analysis and interpretation of ungrouped data, it is very difficult because it is not arranged in a particular manner. But if you look at the discrete frequency distribution and continuous frequency distribution, so it is arranged in a particular manner. So, and it will be helpful for further analysis. Okay. Up to now, we have seen what is a statistics and what is a data, what are the different types of data, and what is the difference between grouped data and ungrouped data, and how to convert a ungrouped data into a grouped data. And there are two different types in case of grouped data. They are discrete frequency distribution and another one is continuous frequency distribution. So now I'm going to explain about the concept central tendencies. Okay, so now let us see what is a central tendency and what are the different types, means what are the methods to find out the central tendency of a given data. Now let us understand what is central tendency. Okay, so now first look at here. Now I'm going to consider one more example for you. It is like this: weight of 20 students of a class 10 is as follows. Okay, 35 kg. Okay, it is actually considered in kg. 35 kg, 38 kg, 38 kg, 40 kg, 39 kg, 51 kg, and so on. Okay, so there are 20 observations, means 20 data. So this indicates what the weight of students of the class 10. So now I'm going to represent this data on a number line. Okay, so now I will show a figure for you. Okay, look at the figure. So now I have written from 32 to 55 because the collected data ranges from 32 to 55. So that's why I have considered so like this, and I have represented the data in blue dots. Okay, so now look at the figure. So now look at here. So after 32, 32 on 32 no dot is present, means there is no student whose weight is equal to 32 kg. That's why I have not written any dot on 32. So now look at here for 32, sorry 33. So on 33 I'm going to write on what? One dot. Okay, so means one student is there whose weight is equal to how much? 33 kg. In the same sense I'm going to move on to the next one. Okay, so now look at here, 34. Okay, one dot means one student is there. 35 kg, one student. 36, there is no student whose weight is equal to 36, and in the same sense 37 also. But when we come to the 38, there are two students here. Two blue dots means there are two students whose weight is equal to 38 kg. And 39, there are two students. Okay, 40 kg, there are four students whose weight is equal to 40 kg. And the next one is 41, two students. 42, two students. And there are no students whose weight comes in this range: 43, 44, 45, 46, 47, like that. And one student 48 kg, like this. Okay, at last 55 kg, one student weighs 55 kg. So now if you carefully observe this representation, okay, so the representation of the data on a number line. So now look at here, we can see in this region. Okay, so in this region I'm going to mark this one. So in this region from 38 to 42. In this region, we are going to see more number of data, means the maximum number of students lies in this region, means weight of maximum number of students lies in this region only. Okay, so by this we can understand what the collected data seems to be more concentrated in this region, means data is accumulated more in this region. So that's why it seems to be the central part of this entire data. Okay, so this seems to be what central part, like that, because we can observe more data in this region. So that's why it seems to be the central part, and we can say the central tendency of this data lies in this region. So that's why the word central tendency indicates what it actually indicates, the region around which the data accumulated more. So that gives what central tendency. Let us suppose, for an example, if you calculate the central tendency for this data, definitely you will get its value nearly between 39 to 40. So from this we can understand what the collected data is accumulated more around 40. Okay, so this is the knowledge we can got from the central tendency. Okay, so now there are different ways to measure the central tendency. Okay, I think you have understood what is a central tendency. So it is nothing but what the region where data is accumulated more, that is called as what central region and central tendency. Central tendency lies in that region. So now there are different ways to find out this central tendency. Okay, so always we can't find out the central tendency by this method, that is in a geometrical representation, but actually we are going to calculate the central tendency by the numerical methods. Okay, there are different methods. So by those methods we can find out the central tendency. We are going to measure the central tendency where it lies. Okay, now let us see. Okay, now look at here. First method is mean. Okay, mean is actually what it is, one type of it is actually the method, okay, to measure the central tendency. Okay, so value of mean indicates what the central tendency of the data. This is the one method. In this mean, okay, after that the second method is mode. Okay, second method is mode. This is the another way to find out central tendency of a given data. And the third method is their median. Okay, median is also another method to find out the central tendency of a given data. There are three different methods to identify the central tendency of a data. Okay, these are all what are numerical method. By numerical calculation we are going to calculate what is the central tendency. If you calculate the central tendency for a particular data by using these three methods, the answers seems to be very close to each other. Sometimes you will get same answer in all the three methods. Okay, but sometimes there will be a little bit error between the answers from mean to mode to median, from mean to median, like this. Okay, it may happen, but there will be a slight error. But sometimes you will get the same answer in all the three methods. So now in mean, okay, while calculating the mean, there are three different methods for you to calculate the mean of a data. There are three different methods, okay, in your textbook. So those three methods are actually discussed, and problems on these three methods are also solved. Okay, now let us see what are the three different methods. Okay, among them, first one is direct method, second one is assumed mean method, sometimes it is also called as shortcut method. Okay, so I think it is not mentioned in your NCER textbook. It is actually in the textbook. He is going to use the word assumed mean method, but in some textbook he is going to give this one as a shortcut method. If you refer Adi Sharma in the textbook, instead of assumed mean method, sometimes he is going to use shortcut method. So that's why remember this word also. Third one, step deviation method. Okay, so these are the three methods to measure the mean. Okay, mean is one type of measure of central tendency. To calculate mean, there are three more methods for you. You can calculate by any method. Okay, direct method or assumed mean or step deviation. And there are formulas to find out the mean by direct method and assumed mean method and step deviation. Okay, now let us look at the formulas. So to find out mean by direct method, the formula is actually like this: x bar is equal to summation fi into xi divided by summation fi. I think the letters are already familiar for you. Xi means it is a data. It indicates what? Data, xi. And fi indicates what? Frequency. Xi is data and fi is actually what? Frequency. In this chapter, wherever xi appears, it is data. Wherever fi appears, it is frequency. Okay, so then for assumed mean method, the formula is like this: x bar is equal to a plus summation fi di divided by summation fi. Here the small a indicates what? Assumed mean. Okay, small a is assumed mean. And the third one is step deviation. X bar is equal to a plus summation fi ui divided by summation fi into h. Here small a is once again assumed mean and h is the width of the class interval. Okay, I think you have studied this one already in the 9th standard. So if there is a class interval 0 to 5, so 0 is called as a lower limit, 5 is called as upper limit. To find out the class size or width of the class interval, both are one and the same. Class size or width of the class interval, you need to calculate what? Upper limit minus lower limit. So the class interval is 0 to 5, then its width can be calculated like this: 5 minus 0, it will become 5. Suppose it is 10 to 20. Okay, class interval is 10 to 20, so then 20 minus 10, upper limit minus lower limit, you will get what? Width of the class interval or class size, and it is equal to 10 now. Okay, for 10 to 20 it is its size is 10, like this. This is called as what? H. Okay, so but in this year, in this academic year, in this chapter, some topics are actually removed. Okay, actually in this chapter, two topics are actually removed. Among them, the one is step deviation method. Okay, so remember now in this academic year, step deviation method is removed. Okay, and I have already sent for you the deleted topics. Once check it. Okay, step deviation method is actually removed, so that's why I'm not going to discuss about the step deviation method later. I'm going to discuss with you only direct method and assumed mean method. Okay, only two methods I'm going to use for you. And the second one is actually what? Mode. So it is also one type of measure of central tendency, but there are no different methods to calculate the mode. There is only one formula, one method. Okay, there is no particular name for that method. Okay, just it has a formula like this: mode is equal to L plus f1 minus f0 divided by 2f1 minus f0 minus f2 into h. Here wherever f is there, it is frequency. So just remember the formula, and the terms will be explained later. Okay, so during the concept of mode, I'm going to explain what are the terms: f1, f0, f2, like that. And h, it is obviously what? Width of the class interval. Remember. Okay, only one method in mode. And in median also, there is only one method, means only one formula. By using that formula, you can calculate median. So okay, now look at the formula. Median is equal to L plus n by 2 minus CF divided by F into H. Okay, so this is the formula. So just try to remember the formula, and the terms of this formula will be explained while solving the problems based on median. Okay, if you study these three concepts, okay, these three topics, mean, median, mode, okay, so this completes the chapter. So first we have to study about what? Mean, and after that mode, and after that median. So in mean, there are two methods, so that's why we need to study both methods, direct method and assumed mean method. Okay, in the next class I'm going to discuss with you the mean, that is a central tendency, the measure of central tendency. Among this, the first one is actually what? Mean. So in the next class I'm going to discuss with you mean, how to calculate the mean for an ungrouped data first. Okay, but it will not be asked in the examination, but just remember, okay, you have calculated mean for an ungrouped data in the ninth standard also. Just I will give one question for you. I'm going to solve one question for you, and after that I will move on to the grouped data. Okay, so there are two different types, discrete and continuous frequency distribution, and we have to calculate the mean for discrete and also for continuous frequency distribution by using the two methods, that is direct method and assumed mean method. So now I'm going to stop the class here, and we will continue this one in the next class. Thank you, one and all.